Lecture 2 of 2. Newton-Raphson Method. If x1 is an approximation to root alpha of fx equals 0, then a better approximation x2 is given by x2 equals x1 minus fx1 over f prime x1. We shall repeat this process as required. And we have a general formula xn plus 1 equals xn minus fxn over f prime xn. This method fails if f prime alpha is near to 0 and f prime alpha is very large. Example 1. Using the Newton-Raphson method, find the solution of fx equals x plus e power x near x equals minus 0.5 to 4 decimal places. Okay, I want you to observe x equals minus 0.5 and we have the word near. So this is actually the initial value or the first approximation. It is stated in the question very clear here. So now we have to use this value to find a better approximation value of the root of this fx using this Newton-Raphson method. Okay, let's do it. So let fx as x plus e power x, and we have to differentiate fx equals 1 plus e power x. And we have a general formula for the Newton-Raphson method, that is xn plus 1 equals xn minus fxn over f prime x. And then we use this formula, okay, and input into the general formula here. So we have xn plus 1 equals xn minus xn plus e power xn over 1 plus e power xn. Okay, and then we start with this initial value or the first approximation. So x naught as minus 0.5. And then we use this to find the x1 when input into this formula. Okay, so we have minus 0.5 minus 0.5 plus e power minus 0.5 over 1 plus e power minus 0.5. And we calculate this, we will have minus 0.56631. And we have to use this value to find the next x2. So you can see, just input into the formula. Okay, and then we have the value is minus 0.56714. And we repeat the same process, okay, in order to get the x3. So we have minus 0.56714. So whenever we change the value just now for the x2, we'll say x3 into 4 decimal places. So we have here for the x2 is minus 0.5671, and the x3 also changed to 4 decimal places. We will have minus 0.5671. So once the value, these two value are the same value when it is changed into the 4 decimal places, so we can stop and conclude the answer. So the required solution is x equals minus 0.5671. This is the 4 decimal places. Alright, so as you can see, this is the first approximation is minus 0.5, then a better one. So you can see this is minus 0.5671, okay, which is more accurate. But then this is still approximately equal, okay, to the root of the fx equals x plus e power x. Example 2. Show that the equation 2 sin x minus x equals 0 has a root between x equals 1 radian and x equals 2 radian. Find the root of the equation by using Newton-Raphson method, giving your answer correct to 2 decimal places. Solution. Okay, now we input this value x equals 1 and 2 into the function. Okay, so we have now f1 as 2 sine 1 minus 1 equals 0.6829. Okay, this is positive value. Then f2 equals 2 sine 2 minus 2 equals minus 0.1814. Okay, this is negative value. So we have positive and negative values, so different sign. So 2 sine x minus x equals 0 has a root between x equals 1 and x equals 2. For the function fx equals 2 sine x minus x, we have to go to differentiate it. So we have 2 cos x minus 1. Okay, and then now for the first approximation value or x naught, okay, you can take any value from 1 and 2. Okay, from 1 until 2, any value you can take for the first approximation. Okay, for this example, I'm taking first approximation x naught as 2. And then I'm going to put this value 2 into the formula. So this is the general formula. xn plus 1 equals xn minus fxn over f prime xn. Then of course, I've got to substitute this fxn, okay, and also f prime xn from this function and also this function. So I will have this, okay, and you can input this formula into your calculator, okay, and all your calculation must be done using the calculator. It is advisable for you not to calculate the value of x, okay, for x1, x2, x3 and so on manually. Okay, you just put all this value. Okay, for instance, we have 2 for the first approximation and we put into x1. Okay, and then we have 2 minus 2 sine 2 minus 2 over 2 cos 2 minus 1 equals 1.9. Okay, this is done by your calculator. Okay, you don't have to go to calculate this manually and you get the answer. And the next one, that is for the x2. Okay, we have to use this formula, this value, okay, this value of x1 and input into the formula of x2. We just write this down, okay, and the calculation is done by your calculator. So we have the value 1.896. Okay, this one we have done once. Okay, this is the second one, and we go to the third one. This one also have got to be, we have to use this value 1.896 into x3. Okay, just copy down all this value and then we calculate. Okay, use your calculator and then 1.895 we have the value. Alright, and for the x4, okay, for the x4 here, you didn't have to write this down anymore because we have done 3 times already, and then just get the answer from your calculator. So 1.895. And then we can go to compare with the before value and we can conclude the answer. Alright, so the required solution is 1.90, correct to 2 decimal places. Example 3. Use the Newton-Raphson method to estimate cube root of 21, correct to 4 decimal places. Okay, solution. Let x as cube root 21. Then we'll have x cubed equals 21. So x cubed minus 21 equals 0. Once we have equated this expression into equate to 0, then we can have fx equals x cubed minus 21. And we have to differentiate this f, so it will become 3x squared. If we go through the question, there is no statement about where this cube root of 21 lies in, in what values. Okay, so we have to determine ourselves. So now we will have here, okay, a cube root of 8 is 2, and cube root of 27 equals 3. And now we have x equals cube root of 21 is in between this value, okay, 2 and 3. So root of cube root 21 lies in between 2 and 3 because of f2 equals minus 13 and f3 is positive 6. So we have here a different sign. Okay, this will confirm that the root of cube root 21 lies in between 2 and 3. So now we can let x note, or the first approximation equals 2. Okay, you can take any value from 2 until 3. And this is the formula for cube root 21. Okay, using Newton-Raphson method. So we have xn plus 1 equals xn minus, okay, minus the function. The function is x cubed minus 21. So if x cubed n, xn cubed minus 21 over 3xn squared. So we are going to use this formula in order to get the next value of x. Okay, we have x1 as we substitute the value of this x naught into this formula to get the x1. Okay, and then we have 3.083333. Okay, then after this we calculate using the calculator. We have 2.791859 and x3 equals 2.759311. x4 is 2.758924. Okay, and then we go to compare this value. Do we have already same value? 4 decimal places. So here we will have 2 point for the x3, 2.7593, and here we have 2.7589. So still have a changing value, and then we have to proceed with the x5. And then by the time we come to this x5, you can see that we have same value already for the x4 and the x5, correct to 4 decimal places. And then after that, the last two value agree, okay, and correct to 4 decimal places. So therefore, cube root of 21 is 2.7589. Okay, whenever you are doing like this, okay, that is without written down the formula for the x2, x3, and also x4. So we can have here, do not leave, okay, do not leave your answer like this. Even though the calculation is correct, but we cannot leave our answer like this. Instead, you have to put the values into the formula for each x in 3 values of x. I mean x1, x2, x3. They have got to be put into the formula. This formula you have to write down. Then only you equate with the value here. Okay, and then just like we have in the example 1 and example 2 just now. And for the x4 and the x5, so you have to write down. Okay, So I hope that you can understand whenever we are doing this Newton-Raphson method, okay, to find approximate value for any function.